Today, we're diving into the story of a truly gorgeous spiral galaxy. From way out here, it looks pretty peaceful, right? But it's actually on a violent journey, caught in a cosmic struggle with its environment. You know, you look at a picture of a galaxy like this, and your first thought is probably, wow, that's beautiful. It's a classic spiral, a real celestial showstopper. But when astronomers looked closer, they realized something's not quite right. So let's meet our subject. This is Messier 88, or M88 for short. You can also find it under the name NGC 4501. It's sitting about 55 million light-years away from us in the constellation Coma Berenices. And yeah, it's a magnificent spiral. But as we're about to see, its apparent perfection is totally an illusion. And that illusion, that seeming perfection, is really the heart of our cosmic detective story today. I mean, think about it. A big, spinning spiral galaxy like this should be more or less symmetrical. So why isn't this one? What kind of force could be out there pushing and pulling on something this massive? Okay, so this isn't your average photo. It's actually a map of the gas inside the galaxy, and it shows something really, really strange. See how one side looks all compressed and squished together? That's what scientists call a high surface density ridge. And the other side? It's all diffuse, kind of stretched out. The entire galaxy is lopsided. To figure this out, we have to zoom way out. This is one of those classic cases of, hey, it's not you, it's your neighborhood. You see, M88 isn't just hanging out in empty space all by itself, not at all. It's a member of the Virgo cluster, which is this huge collection of over 1,000 galaxies, all gravitationally bound together. And believe me, it is not a quiet neighborhood. The space between all those galaxies isn't empty either. It's filled with this incredibly hot but very thin gas. They call it the intracluster medium. Just think of it like a giant, invisible superhot atmosphere that all the galaxies have to move through. So what do you think happens when a galaxy, speeding along at hundreds of kilometers per second, smacks right into this invisible cloud of gas? Well, it feels an incredible force, basically a cosmic headwind. Seriously, imagine you're driving in a convertible, with the top down, going super fast. You feel that wind pushing your hair back, right? It's the same idea here, just on a scale that's almost impossible to imagine. And scientists have a pretty awesome name for this whole process: ram pressure stripping. It's a force so powerful it can literally strip away a galaxy's gas. You know, the very stuff it needs to form new stars. It's stripping away its lifeblood. So here's how it goes down. The galaxy plows into the cluster's gassy atmosphere. Bam! The gas on its leading edge gets slammed and compressed. At the same time, the looser gas on the trailing edges just gets blown back and stripped away, forming a tail. And this process, it perfectly explains that lopsided shape we see in M88. But you know, it's a great theory, but how can we be absolutely sure this is what's happening? Well, this is where some incredible science, a mix of real data and powerful computer models, gives us the proof. Astronomers have found all these different lines of evidence. They're like cosmic fingerprints of this headwind. We've already seen the lopsided gas, that's a big one. But they also detected a compressed magnetic field piled up on the leading edge. They even found little pockets where new stars are being born, triggered by all that pressure. Everything points to ram pressure. All that evidence is pretty compelling for sure, but the real smoking gun, the moment that just makes you go, uh-huh, is when you take all that data from the real galaxy and put it right next to a computer simulation of what ram pressure should look like. And just look at this. On the left, that is the actual observation of the gas in M88. And on the right, that's a computer model showing what ram pressure should do. The similarity is absolutely stunning. The model perfectly recreates that dense leading edge and the stripped gas on the other side. It's an unmistakable match. And it doesn't stop with the gas. It holds true for the galaxy's magnetic field too. Again, on the left, you've got observations showing the magnetic field lines all bunched up on that front edge. On the right, the simulation predicts the exact same pattern. This is as close to a perfect match as you're ever going to get in astronomy. So, we've solved the mystery of M88's weird shape. But what does all this mean for its future? We're not just looking at an event that happened. We are witnessing a snapshot of a galaxy in the middle of a massive transformation. Right now, M88 is taking this cosmic plunge, heading straight for the heart of the Virgo cluster. In about 200 to 300 million years, it's going to make its closest approach. At that very moment, the ram pressure will hit its absolute maximum, and it's going to violently strip away a huge chunk of the galaxy's remaining gas. We can even plot out its journey. Look, it's heading right for the densest part of the whole cluster, home to that supergiant beast of a galaxy, M87. This is not a gentle fall, folks. It's a high-speed dive that will fundamentally change M88 forever, slowly turning it from this vibrant, star-making spiral into a much quieter, gas-poor galaxy. So when we look up at the night sky, galaxies can seem like these peaceful, unchanging islands of light. But the story of Messier 88, well, it shows us what's really going on. They aren't just objects. They are travelers on these unbelievable journeys, constantly shaped by their violent environments. And it just makes you wonder, doesn't it? How many other beautiful galaxies out there are in the middle of their own chaotic transformation right now?